Hi, hello everyone, and welcome to this session. I really hope that you're enjoying the conference so far and that you can stay with me the following minutes so we can go over this interesting topic. This session is from discovery to implementation using the AsyncAPI ecosystem. In the following minutes, as I was telling you, we're going to go over the different elements of an EDA that can be of help from the AsyncAPI initiative with their tooling and with their ecosystem. So let's get started. Okay, first, let's do some introductions. My name is Hugo. I'm part of the developer advocacy team in Red Hat, and I'm specialized in APIs and messaging. I do like to travel. I like travel to get some very interesting food, history about the place where I'm traveling, and such. So I will have loved to be able to join all of you in Barcelona, but well, I hope next year we can do it. I'm a Mexican, currently based in Massachusetts in the United States. And here is some information about my Twitter account if you want to follow us or you just want to get some more information of what we are covering today, or you just want to have some links to the YouTube channels, to the different blog posts that we have, you can certainly follow us there. Let's talk about the first interesting topic. So the thing we're going to be covering today is EDA, or event-driven architecture. And the interesting thing here is that we have been doing EDA for a very long time. It's now on the rise because of the new distributed architecture and microservices that are being the norm in the cloud computing. But we have been doing EDA for a long time. So since the beginning, when we were just working with mechanical computers, there was interruptions, and those were events that need to be captured and be able to respond upon that. So this is basically the core center of what EDA is. And we can see this in this diagram. So we have a consumer and a producer. Each one of those needs to be able to exchange information or exchange data, events, messages from the producer that is, sending the information, as well as the consumer that is supposed to be the target that will be receiving the information. So there's one of the challenges that we have with traditional REST APIs is that both the producer and the consumer, or the client and the server, need to be online at the same time and being able to then communicate, establish a connection, communicate, exchange information. However, there's some limitations. It's like, okay, what happens if I don't have connectivity, or if I just need to be able to send information later, and so on. And this is where the pattern of store and forward becomes very useful. And to implement this pattern of store and forward, we need this middle piece of the architecture that allows us to delegate the delivery of the message or the event from the producer to the consumer. So basically, we have a seamless communication between the publisher and the message broker, where they send the information, and then the message broker takes ownership of the message, and then it's in charge of delivering that event, that message, to the different consumers that will be listening, or that will be interested in receiving those messages. So there's a lot of different type of consumption patterns for the messages, where you have events that can be discarded, events that needs to be delivered to a specific consumer, events that needs to be able to stay for a longer time in case that the consumer wants to replay them, wants to reread them, receive those, and such. But the basic is still there. We have this middle element in the architecture that it's a broker or the boss that takes ownership of managing and delivering those messages to one consumer, multiple consumers, and such. And this piece, it's also interesting because there's a different type of pieces that implement this pattern. So if you have been doing mainframe, you have been doing other type of architecture, you certainly have been facing the concept of queues and the concept of topics available in all these brokers, right? From Kafka, that's the owner topic replayable events. IBM and Q has been forever. ActiveMQ, Rabbit, Solus has a lot of work been doing on PubSub, as well as Google, Nats, Redis, that originally was more on the cache side. It's also implement events and so on. So you can find a lot of different software that it's implementing this concept of the broker or the boss. And this is important because there's different type of protocols. There's also different type of implementations on how to handle this pattern. And this makes it a little bit more complicated than just, having an HTTP connection. But let's go a little bit more on down with the history. So in the beginning, as I was saying, we have been doing EDA for a long time. In the beginning, most of the EDI was done within one single team or one single organization. So the need for external access to our topics or queues was really more like limited space, or it was easy to control who were accessing to those queues and topics. So, sending them over a PDF file with all the different information on the endpoints, security, and the payload that will be received on those queues topics was, something easy in there. But then in the other side, and in the next room, people were doing REST APIs. They decided to be able to use them externally and share with partners, and API economy started, and we have now them be able to expose our APIs publicly and be able to socialize them, to be able to get information and feedback around this. So this certainly made them have to react and create a crafted ecosystem that allows them to make that easier than before. So for that is that they start to create things like open API specification and such. And in the EDA world, we really stay on our line, and we're just looking at what is going on in the other aspects. And until we started to be faced with consumers trying to access our events, and getting the notion of and the benefits of EDA and how to consume them, in the broader scope. So that's why we started to work on something like the AsyncAPI Initiative that will be trying to address the ecosystem around APIs on EDA and EventDriven. And this is how the initiative started with the specification. So the specification started to basically be a way to implement something similar to the OpenAPI specification, but for event-driven architecture. So if you're coming from REST API world, you will certainly see that the specification is very similar. It's sharing a lot of information regarding servers, security, paths, consumption, and payload, for example. It's very clear that the payload is one of the interesting and most important things about our API. So the initiative started with the specification and how to be able to implement that and create that. But when working with things like specification, schemas, things like that, you certainly need a way to be able to validate them, to work around them. And this is where the initiatives start to switch, not just from the specification as a document, but also around the tooling that will help us to manage, interact, and work with that specification. So the initiative went broader and started to work on this tooling from editor, parsers, generators, and things like that. So the idea is that all this ecosystem and all these toolings within the specification initiative, or from other vendors or from other open source projects, can broader and can help you to deal with your APIs. And this is why we have the API lifecycle. You know that when you are working with a specification, where you are working with APIs, we have this infinitive loop that tells us that we need to go from a certain a continuum of delivering our APIs, being able to consume them and such. So it's basically a life cycle, a process for that. In the REST API, it's a little bit more mature. The EDA side is perhaps a little bit more complex within what we can do right now with the current state of the art. So we still are able to do design of your API. You can still do things like mocking or testing of your API. You can then implement the server side for a certain kind of bindings or certain kind of elements of the broker that allows you to implement how you're going to be handling the interaction with your consumers and producers. But also there's the part of the socialization of your API. So how you do discovery, how you do socialization of your APIs, how do you implement the developer portal and such, in a way that then you can enable other developers and other applications to be able to consume your API. So we will be able to then take these different stages and phases of the API lifecycle, from design, mock, testing, implementation all the way to the consumption of your API. So let's start with some of the examples. So if you are doing the design, there are different ways to get started, right? So when we're talking about the design and contract first approach, we say, okay, we will first create the contract, define what is the expected workload, the expected points, but no one single line of code needs to be written at this time. And for that, there are different tooling that can help us with that. So there's things like the AsyncAPI Studio that is part of the initiative. There are other open source solutions like API Studio that also have the opportunity to be able to design your API following a form-based approach. Swagger Hub also has support for AsyncAPI. And this is when you're doing, like I was saying, the design-first approach. But in the case that you are already trying to grab your event-driven API from a current existing instance, for example, you already have a Kafka broker that is receiving and sending events, then you can use things like the Solus event agent that can be used to get a discovery of the different topics that are available on your Kafka cluster, also the kind of events that are flowing through those topics, and then being able to auto-generate an AsyncAPI document from that information, and then so you can get the definition of that. So there's other different type of toolings. This is just an example. You can certainly explore them further and see how they can fit if you're doing either design first approach or code first approach, where you just want some annotations on your code and being able to generate the specification. As I was saying, if you're starting from code, you can go with the Go Java AsyncAPI. You can see the example. You can just add annotations to your code, and then the plugin can read those annotations and then be able to automatically generate the specifications. You can expose that Springwall. EventBridge Atlas also allows you to do the same for AWS EventBridge. So there are more of those that allows you to get an existing code and implementation, and then being able to generate the specification for you. If we are talking about mocking and testing, well, there are other different tools that also benefit from the AsyncAPI specification when you define examples in the specification, and then you are able to create these mock servers that will be automatically generating payloads that you can try your consumers and be able to receive that information. So you have things like Macrox, and also you have VirtualLAN, multi-API converter. Spectra also helps you to do testing. Macrox also do a little bit of testing based on the contract, so it can check if the generated event or from your producer is really in sync or in line with the expected schema and specification from your AsyncAPI. So there's a way to then be able to parallelize, being able to mock your APIs while your team's working on the implementation. Your consumers can start to work with those and see how they are receiving events through the different bindings and such. For testing, you can also do not only testing of the actual topic, but also topic or queue or endpoint. But also you can do some kind of testing of the AsyncAPI, like doing some linking. So Spectral is one of the tools that help you to validate that your AsyncAPI generated it is being tested along some certain rules, and validate that everything it's according to what is expected from that AsyncAPI. So when we talk about socialization, there's different ways to share your API. So you can go to public directories like APIs Guru or API Tracker, or you can submit your information and you can see what available endpoints or specifications are already available. These are not as as common or popular as some other REST API directories, but well, this is a way to get started. This is only if you want to go public and you really want to expose or consume somebody else's documents, but also you can go internally, and if you want to just socialize and share your APIs with other members within the same organization, you can deploy on-premise toolings like the API Courier registry or your own developer portal, where you can then publish the AsyncAPI specification, and then being able to use some toolings to automatically download and generate stubs or source code from those APIs. So you can also do internal or external type of socialization of your API. Now, let's talk about consuming. And this is perhaps where you will be spending most of the time, or where you have been, seeing a lot when talking about the ecosystem for AsyncAPI. Most of the times it is because you already are being provided with an AsyncAPI specification document, and then you want to consume or you want to connect to the service and being able to start interacting with that. So that's why most of the times you will be hearing about this specific step in the life cycle, when you are able to consume and get really the benefits of the API owner that is exposing this event-driven API. And there are different projects and different applications that allows you to get started with this. So the first one is part of the AsyncAPI tooling. Is the generator. There's an option to be able to run an application that will take the specification, analyze the different content that is available on the specification, and then generate a template, a stop, or some basically sample code that allows you to get started with your business logic. So basically adds the libraries required for your application, starts the code, set up the connection, perhaps the configuration for the connectors that you will be using depending on the language, depending on the different libraries that you're using. And this is where there's a lot of work being happening. Obviously, there's other vendors that are also implementing something similar to generate code from different applications. And some of them are, for example, for specific solutions like a Node-RED plugin that allows you to take a specification and being able to start crafting on a more visual way. So multi-API generator, there's another option that allows you to generate your code. And if you're going to develop for a specific type of languages like C++, there's also generators that allows you to do that. So you will find a lot of information. It's one of the easiest way to get started, to be able to, scaffold a lot of the code, bootstrap it, and avoid to having, to create all of these kinds from your own. There's a lot of libraries for different languages that are already available. Okay, so we went over the different concepts of the ecosystem of the API lifecycle of what is an EDA. The important thing here, this is what I really want you to have as a takeaway, is even though we think about AsyncAPI as just the specification or just the contract or just the definition of how we are going to be documenting our event-driven APIs, it is more than that. It's a whole ecosystem that it's growing and that it's vibrant and where you can participate. That in a way that you will be able to create this tooling, to be able to use that, to give feedback on that, and that it's under either the domain of the AsyncAPI initiative, the team that is working with them, or you can also see that there's other vendors that are also having a lot of projects that are being open source, where you can go check them out, see if there is something that is working for you, and also you can contribute to those projects back through just raising an issue, being able to do sample PR and such. The idea is that when you're working with event-driven architecture, you are not alone. There's this AsyncAPI that will certainly help you to be more successful, and the whole ecosystem, the whole set of tools that now you have on your tool belt to be able to build and create event-driven architectures. Okay, remember, as I was saying, a lot of this ecosystem, it's under the AsyncAPI specification. So if you want to work directly with the team, join the AsyncAPI team through conversations, GitHub discussions, issues. You can follow the Twitter account. You can just hang out with the folks around that are contributors, either part of the committee or part of the ambassadors as we are. So please remember to join the community and provide your feedback and what is working, what is not working. It's very valuable for the whole ecosystem to be able to get that. Again, thank you very much for this time. I know we covered a lot of ground. There's a lot of things from definition of EDA all the way to the API lifecycle, the different steps and different tooling. So I invite you to go again, visit the AsyncAPI site, go under different tools, so you will be able to check what's going on. It's always been updated. If not, here's again my Twitter account. You can certainly follow us, follow up us, and be able to see what we are publishing, what we are sharing, or just you can bootstrap the conversation over there. So again, thank you very much. I really appreciate the time you spend with me, and I hope you can enjoy. I continue enjoying the rest of the conference. And if everything goes good, just stay safe and see you next time. Again, thank you.